Hi everyone, I am an analyst from the engineering consulting group known as Calidosos. This group is conformed by the Gulis Hurtado, Santiago Prado, Juan Esteban Londoño, and Arnold Chari. We're going to expose you our model in order to satisfy the weekly demand for 4 types of products that are going to be sent to several cities that are Cali, Medellin, Bogotá, Barranquilla, Bucaramanga, and Pereira. The shortest production time is search, and we have this is the route. We hope you enjoy it.
Okay, here in the port is where the process began. Because first, the sheets arrive here and is where the trips to the factory are made. Our 4 important decisions are, in the Excel, we're going to see. Here we got the total demand of a week of all units for each series. Then we got the mensual demand, then the sheet demand, and for total trips, we have the total demand of sheets divided into 300 that are the maximum capacity of our trucks. Okay, here in Flexing, we have our distribution of the sheets. As we can see, we have a uniform distribution to obtain a better result at the time of transport and processing on the factory. Also, we take the decision of the max speed of the truck, that is 0.96 kilometers per minute. Now we get in the factory.
Okay. After the port, we have the fabric. This is the fabric here, as you can see on the model. This is the place where the products are processed. First, the sheets are processed to obtain 2 units of a product. Next, the products go through different stations like lathe, milling, drilling, and inspection. At the end, the products are organized and prepared to go to their destinations. The decisions we make are as follows. First, we establish an initial inventory at the production plant. Secondly, a batch production sequence was chosen for each product. We did this with the process flow. Third, we decide the number of machines per station to meet the demand. And finally, we establish the time in which the products arriving from the port must re-enter production. So a cycle is generated to meet the demand every week.
For the distribution process of the simulation, we determined that Pereira, Bucaramanga, Barranquilla, and Cali only needed 1 truck for the distribution of all units, whereas Medellin and Bogotá needed 2 trucks. The maximum capacity of all the trucks were 500, but the second truck of Medellin had a maximum capacity of 90, and the maximum capacity of the second truck for Bogotá was 300. All trucks had a maximum velocity or speed of 0.96 kilometers per minute, but the only exception was the truck to Barranquilla, which had a maximum speed of 0.76 kilometers per minute. The main data we collected from the simulation was the distance traveled in kilometers. The 2 highest values were the truck from the port at 1,035 kilometers and the truck to Barranquilla at 1,061 kilometers. In the chart here, we can see all the data complete, the amount of units produced by hour, the amount of time each product spent in production by type, the amount of units that were produced by hour and sorted by type, and the general state of all the servers. It was a 53.42% in the processing state. The amount of units that were ready to sell were 470 for Cali, 335 for Barranquilla, 240 for Bucaramanga, 205 for Pereira, 800 for Bogota, and 590 for Medellin. Sorted by type, the average stay time in the processing state for each type of product was 36 hours for product 1, 69 for product 2, 44 for product 3, for type 3, and 60 for type 4. The total cycle of the production was 50 hours, and the total units that were processed were 3,069 units. In these three charts, we can see the processing state, the setup, and the idle state for the lathe machine, for the milling machine, and for the drilling machine. And finally, in this chart, we can see the total processing and idle time for the inspection state. The last graphic, we can see a table where sorted by type, we can see the amount of units that were processed. It was 1,083 for type 1, 736 for type 2, 660 for type 3, and 590 for type 4.
Finally, we are going to evaluate the strengths and weaknesses of our model. The main strength is that our model is able to satisfy the demand in a week. It's important because it's not necessary to simulate more than a week, because just with a week, we are aware that the programming is valid for satisfying the demand in a month. And in the weaknesses, we have that there's a lot of idle time. Also, the enlistment time is a reason that the production time is very high. And finally, the shifts should be reduced because there are a lot of shifts. With 2 shifts is enough. Thank you.